Four scientists made quite a commotion when I invited them in to create a potion. Into 4 glasses went the reactive brew, and into a rage the first scientist flew. She shrieked, "Ah!"
There's no reaction in this drink. For it to be basic, it must be pink.
The second scientist laughed.
The pink is here. Pour your brew in. The color will appear.
The third scientist shrieked,
Ah! We need more!
And gave her brew to scientist number 4.
Now there are 2 glasses of pink, but no one asked me what I think. I'll neutralize this solution with acid to make it clear. Be gone, pink. Watch the color disappear.
Did you get all that? Although the cups look like they have only water in them, there is really a super secret potion in there. Well, maybe not so secret. Cups number 1 and 3 have phenolphthalein added as an acid-base indicator. Indicators change color depending on how acidic or basic a solution is. Phenolphthalein turns pink in the presence of a base. In cups number 2 and 4, ammonia was placed. So when number 1 was poured into number 2, the solution turns pink because the phenolphthalein is added to the ammonia, a base. The same is true of cups numbers 3 and 4. The real magic comes in at the last step. What appears to be an empty cup really has a few drops of vinegar inside. When the pink solution is poured into the supposedly empty cup, the solution turns clear. This happens because the vinegar neutralizes the ammonia. This solution is no longer basic and loses its pink color.
We use acid-base indicators to measure the pH of a substance. There are a few ways of doing this. Using litmus paper and universal indicator are the most common methods. Acids turn litmus paper and universal indicator red. Bases turn them blue. When we mix acids and bases together, a reaction occurs which we call neutralization, since it creates a water solution. Water is a neutral substance with a pH of 7, hence where the name neutralization comes from. Red and blue make purple, right? Wrong! Neutral for universal indicator appears as a yellow color.
We're not out of demos yet. This one is called Mom to the Rescue. I'm sure at some point you have had a stomach ache or heartburn. To alleviate your symptoms, your mom probably told you to take some sort of antacid. Here, we're going to use milk of magnesia for our example. It is cleverly abbreviated MOM and is sold in liquid form. Milk of magnesia is really magnesium hydroxide, a common base. The beaker represents your stomach after you have taken in an acid with some universal indicator added to help us keep track of the pH. To begin, magnesium hydroxide appears bluish purple, so we know it's a base. As acid is added, the solution begins to change color, showing that the pH is changing as well. Just as stomachs don't stop producing acid, we won't either. As more and more acid is added, the color changing happens for a longer amount of time. It is taking longer for the magnesium hydroxide to neutralize all the added acid. Eventually, all the magnesium hydroxide is used up. This is evident because the solution is no longer cloudy. Therefore, there is nothing to neutralize the acid, and the solution remains a bright pink color, showing that the remaining solution is an acid. Mom says it's time to take more.
Acids and bases have 2 different faces, 2 different personalities, and you gotta find out what they're all about if you wanna learn chemistry. Now the first thing you gotta get straight in your head: acids turn blue, litmus paper to red. Bases are different from acids, it's true. Bases turn red, litmus paper to blue. Well, there's even more to this wonderful tale, something we call a pH scale. It numbers from 0 up to 14. Those are powers of 10, if you know what I mean. Acids and bases, now why should you care? 'Cause acids and bases are everywhere. Acids and bases have 2 different faces, 2 different personalities, and you gotta find out what they're all about if you wanna learn chemistry.